Hello, ladies and gentlemen. Today I will show you the real physics behind action movies. The selected clip is from a 1994 movie called Speed. Here is the clip. Wow, that's a supernatural bus, because at the bridge gap, which has the same level between two sides, the bus magically moved at an angle without any incline and landed safely. So what should be going on? Well, in reality, without an incline, the bus will be a horizontal projectile, which means the initial velocity in the y direction of the bus is zero, and the bus will move at a constant velocity horizontally. However, there is also the acceleration due to gravity influences the bus. As a result, the bus will be pulled down and crash at some point on the other side of the bridge. So, in order for the bus to land safely, the other side should be either lower level or there is an incline for the bus to jump off. In this video, I will calculate both ways. Firstly, from the previous part of the movie, the character said that the distance between the gap was
50 feet.
Well, 50 feet can be also converted into 15.24 meters. Then, looking back the snapshot of the movie, you can see that the bus was traveling at 67 miles per hour, which was also equal to 29.95 meters per second. Now we can start our calculations to find delta dy. By using Mr. Smider's 6 simple steps to solve a problem, we can jump to the step to write down the known values and the formulas to use. Next, substitute the values into equation delta dx equals to Vx times delta t in order to find the time the bus will fall. Finally, substitute delta t for v1y and the acceleration due to gravity into the equation delta dy equals to v1y delta t plus 1/2 ay delta t squared to find delta dy. Now we get the value of delta dy, which means that the second edge of the bridge should be built 1.27 meters lower than the first one in order to make the bus land on it. Now we can also calculate the angle of inclination theta at which the bus can land on the other side. Assume that there is no energy loss from the bottom of the incline to the top of the incline, which means that the velocity at the bottom will be the same at the top. Notice that when the bus reaches at the highest point, the velocity in the y direction will be 0, and displacement will be the half of delta dx. Using that information, we can calculate delta t at the highest point. Then use the equation v2y equals to v1y plus ay delta t. We can find initial velocity of the bus in the y direction. Finally, we can use the formula theta equals to inverse tangent v1y over v1x. We can find the angle theta at which the bus can land on the other side, and that is approximately 5 degrees. So, how was the scene really made in the movie? Well, I found a YouTube video about it. It seemed that they also set up an incline for the bus to jump off. However, as you can see, when the bus landed on the other side, there was several damage on it. There was damage on the front and the back of the bus, and the bus was also leaking oil. However, in the movie, the bus was not so damaged. In conclusion, this movie clip didn't follow physics laws in several ways. Firstly, the bus didn't fall down as a horizontal projectile. Secondly, there was no incline setup in the movie, but the bus magically moved up an angle. Lastly, there was no consideration of damage on the bus. However, how many movies today are still realistic and obey physics laws? Maybe we can just have fun when watching them as a relax.